What's up, YouTube? In today's video, this is like a part 2 of the roles and responsibilities of a configuration provider. Now, if you think you know what a configuration provider is and what's the problem with that or how simple is that, why am I making this video? Please watch this video because very few people understand the roles and responsibilities of a configuration provider, as a result of which I'm making this video, of course. And in this video, being part 2, is that I'm looking at the .NET Core version. The previous one was .NET Framework version. Now, there's not a whole lot of difference. So I will be spending some time in the roles and responsibilities of the configuration provider initially, as well as I go through. In the description, you'll find the timeline or the time codes for the different parts. And that way, if you want to skip to a specific part, you can skip directly to that. All right. So the roles and responsibilities of a configuration provider, why is there even such a thing? I mean, how complicated is it? It's not the complexity. It's the knowing of what to and what not to do, or what the configuration provider should be doing and not doing. And that's the key aspect. So I'm going to show you the configuration file here. This is the app settings.json from the .NET Core aspect or side of things. And you can see here there's app settings that one's called the email template path, the payment gateway service URL, fiscal year start, etc., etc. Step 1 is the names. Where do the names come from? You want to make sure the names in your config file, the name of the settings, is the same as how you would know this in your system. That is, you don't want to have different names. You don't want to have some, stupid name A or B or something here in the config file, while in the system, you know it as a completely different thing, or it has a more meaningful name in the system. But it goes beyond that. Not only is the name, let's say we look at email template path. So the setting is called email template path that has, let's say, a meaning in the system. Then the method will be called get email template path. Everything about this specific setting in your entire system will have the same name. So there's no confusion about what this setting is and what it means to the system internally, what it means to the business, what it means to the dev team. The whole shebang has to have the same name. Right? So that's the one aspect you have to be sure of or understand is names are important, and the name should follow through in method names, property names, and so on and so forth. And these names, of course, you want to pick are those that are known by the business. Secondly, if you haven't seen my video on programming with intent, then please take a look at it over here. This setting or this idea of when you lock the front door and you lock the back door, you're safe in the house. I describe it over there, but there's a whole lot of other stuff I talk about in that video. But in this video, I'm just going to be talking about the front door, back door thing. So I'll explain that. I'll say it and then I'll explain it. I have a saying that says, if you lock your front door and you lock your back door, you're safe in the house. What that really means is, imagine your system has two doors, the front door and the back door. The front door is typically user input and maybe it's a service or some other systems are calling your system. They're sending you data. That's your front door. The back door could be, hopefully not, but it could be your database. I say hopefully not because I've had a situation where I could, trust my own database. Yeah, that also happens sometimes when you inherit a system from somewhere else, or they've not been careful about the data that went in the database in the early days or in the beginning of that system's sort of lifetime. You now have crap data in your database, so you can't trust that data either. But mainly it's data that comes from other services. Right? So that's your back door. If you lock the front door, meaning as soon as the data comes into your system, that's your front door. If you lock it, meaning you don't allow crap coming into your system. You validate, you clean up, and after doing all of that, if you don't like what you see, you throw it out. So that's what I mean by lock the front door. Lock the back door, it means the same thing. If data comes in from your database or from another service that you've made a service call for, and the data is not something you like or agree with or cannot handle in your system, you throw it back out at the point of entry into your system. Don't let bad data come into your system. What's that got to do with the configuration provider? It's your back door. It's another door through which data comes into your system. Data from a config file that is human written, if you will. So that's as good as a user. You can't always trust that data. And so you've got to lock that backdoor. So one of the roles of the configuration provider is to lock the backdoor. And I'll explain a little more. Okay, so if you look at the data here in the config file, you'll see that fiscal year start. That's a date time. How do I know it's a date time? Well, I can see that. Is that good enough for you to trust that that's a date time? Of course not. The config provider, however, is aware that that is a date time, and that's supposed to be a date time, and it has to be parsable from a string to a date time. That rule or that knowledge is baked into your configuration provider. That's another responsibility of the configuration provider, is to provide you with strongly typed information from your config file. Whether it's a database or a config file, it really doesn't matter. It's another backdoor. And the configuration provider's role or responsibility is to ensure that any data that comes into the system is correct or good or clean. But that also implies strongly typed. In other words, your configuration provider's API has to be strongly typed. It's not dealing with strings all the time. It may not be, like in this case, it's got a date time. So your signature of your API of your configuration provider will say that there's a property called fiscal year start and returns to you a date time. If the data that is in the config file is not parsable to a date time, the config provider needs to throw an exception immediately saying there's something wrong here. This thing, whatever the value is not a valid date time. So you don't have bad data coming into your system. You're not trying to deal with that problem deep in the guts of your system. The same goes for notify on upload. It's a bool. Now we can see it's a bool, but the config provider's signature has to ensure that it returns a bool, not a string, a bool. Even if it's a true, false, or a T and F here, or a 0 and a 1 here in the config file, it really doesn't matter. It needs to define that as a bool so that in your system, you're treating it as a bool, not some string or a bit or whatever the case may be. So there's just some examples of strong typing where you're dealing with different data types. The system, your configuration provider, knows that there are certain data types and it has to bake that knowledge into its API or into its signature. So if you were to look at the base class here, you will see, and I've got a lot of comments in the code to explain some of the details that I'll skip over. This code will be available on my GitHub. There'll be a link in the description below. You can go get the source code from there. The previous project, the .NET Core version of the project, is also available on GitHub. So if you're looking at .NET Framework, you can look at that video and that project. If it's .NET Core you're looking for, then you can look at this video and the source code for the associated project. I've defined a few things. In the comments, I've sort of provided the requirements, if you will, so you understand what the purpose is. So if you look at the date time fiscal year, you can see the signature says it's a date time, right? It's not a string, it's not a bool, it's not something else. It's a date time, meaning from within your application, when you access this configuration provider, you know it to be coming back as a date time. Now, the date may not be valid. That's a different problem. The config provider doesn't understand what dates are valid dates. But what it will ensure for you is that it is a date time, right? So there are certain roles and responsibilities, and beyond which is sort of beyond the responsibility of the config provider also. That may be a business rule that you understand in some other part of your system. The config provider doesn't understand that detail or that depth of it doesn't have that knowledge, right? It knows it's a date time. It doesn't know whether it's a valid date that is giving you back or not. The same with notify on upload. It's a bool returning property. So same thing, it doesn't know whether true or false is the right number or the right value, but it knows to make sure that it's a bool in the config file. It's parsable. Now, whether it's a T or an F or a 0 or a 1, however you want to implement that logic within the config file, the actual file itself is not really the concern. It's more about what is the API of the configuration provider to the rest of your system, right? It's the backdoor. And can only allow valid data coming in through the backdoor. By valid, I mean at least data type perspective, it should be valid, the right data type. Then there are other ideas within the config provider that you bake. I call it bake it into the base class or your configuration provider. Is which ones are required and not required? Which properties are required and not required? So, for example, if you look at this thing here, and I've just made this up. In fact, some of it is from a real system, but I've kind of altered it just to have a full-blown example here, a real-world example. So you'll see things like it'll tell you in this case whether it's required or not. So this is not optional. Right? So this property is required. It's not optional. That knowledge is known to the config provider. So it understands. It knows that some properties are optional. Some properties are not. They're required. And in other case, it could say, well, if it's not there, I know what default to use. So there's lots of that knowledge, if you will, that is the role and responsibility of the configuration provider itself. And I explained some of that over here in the summary information you'll see on top of every property. So in this case, it's not optional. So it has a method internally called get configuration settings value throw if not found. Because this property is not optional, it has a method that says get it, but throw if it's not found, right? So it's kind of baked into in this case, our base class. Now the base class in this project and in the .NET Framework project are identical. I might have changed a few little things with regard to exceptions, but for the most part, they're the same. They're identical. I'm not trying to say you need to have a configuration provider that's compatible across .NET Framework, .NET Core. That's not really the point. But it so happens that I've just used the same base class for this project as well. And if you're not aware, if you haven't seen the first video, you should also know that the next step of this effort here is to go down the route of unit testing. So if you haven't done unit testing or you're not very comfortable with unit testing, then that'll be a good place to start the next video I make on this topic, because it's going to introduce you to the idea of unit testing and how to go about thinking about unit testing. Not so much an introduction. I'm not going to take you through every dot and period within the unit testing idea, but you'll certainly get a good idea, a good grasp of how to do unit testing, or how you should be doing unit testing, not from a C# perspective or the coding perspective, but the concepts about unit testing, right? So anyway, going back to this, there are some cases, for example, let me find so this property over here, it says the property returns the base URL for the credit card payment gateway. This property is required, so it's not optional. So this property is also a required property. If the URL configured in the config file does not end with a /, then this property will append a / at the end of the URL, return it rather than throwing an exception. And this is something I do for every URL in my config file. I sort of establish a standard, which is all URLs must end with a /. That way, in your system, you're not trying to account for, well, in this URL, there's no /. I have to add the / to append something beyond that base URL. In other cases, I don't know. So it's like this, I don't know, maybe, we don't want to be in that situation. So the standard, if you will, that I've been applying for many years now in my configuration files is configuration providers, because irrespective of whether the file itself contains a ending / or not, the config provider will always return that URL with the ending /. And as you can see in the description, it's not going to throw an exception saying, hey, you don't have a / at the end. I mean, how much does it take to add a / at the end of the URL that's in the file in the first place? So again, I'm trying to show you the role and responsibilities of a configuration provider. So in this case, one of the things that I said with the URL, I always ensure my URLs end with a /. Whether the URL was ending in the / in the config file or not is irrelevant. The configuration provider will handle that scenario. Right? So it has the notion, it understands that a URL should end in a /. Then the other things like the DateTime over here, you can see it says this property is an optional property. If the setting does not exist, this property should return 1st October 0001 in this format, MMDDYY format. So it should be 10/01/0001. So this is also a rule that you can bake into. I'm just coming up, as I said, with some ideas or examples of what is within the realm of the roles and responsibilities of a configuration provider and what is not. In this case, the config provider knows that if it didn't find a date, it should default to that date, the 1st October 0001. But if it does find a date, that date bloody well be a valid date time, because it is going to ensure that date in the config file is a valid date time and can be parsed in this format of MMDDYY and return that to you as a date. Now, that date may not be valid in your business. It's the date, but it may not be valid in the business. That's a different problem. That's somebody else's responsibility. It's not the responsibility of the configuration provider. So you got to be very clear when you demarcate, when you define these lines between, let's say, some other class and the config provider. What are the roles and responsibilities of the config provider, and what are the roles and responsibilities of some other class, right? All right. So you can take a look at this class, study it. I'm just going to show you the other parts that are there. I'm just going to talk about some of the methods that are in this base class and that are implemented. As you can see, this class is fairly well implemented. And that's also by design, because again, it's not about the .NET Framework versus .NET Core. But let's say today you're accessing the data from your config file. Tomorrow you decide to get the data from a database. The day after you decide to get it from a service, let's say sitting in Azure or someplace. So the idea is you don't want to lose any logic, any rules, any responsibilities just because you have a different implementation. So when you design a base class and a descendant, you're thinking in those terms. What is changing in the descendants? And leave only those aspects in the descendants, but bake everything else in the sort of the base class. So no matter what the implementations are, they will all inherit that base core functionality that you don't want to lose because somebody implemented something incorrectly and so on. Now you lost that feature, right? So all of these rules, if you will, of what's required, what's not required, what the default values are, etc., is all baked into the base class. The base class furnishes some methods like get config setting value. Given the key name, it'll get the value now. It turns out, and again, I'm using this as more of an example, that the way you access the config system in .NET is quite a bit different from .NET Core. So the only change between the configuration provider and the other project and this project is how do you access the actual setting value. But once you've extracted the value from the config file, the rest of the logic resides in the base class. And so it's important to understand that there's no difference in the base class. It's only the difference in how do you get the value. So tomorrow, if you were to get the config values from a database, it's how you access that value from the database that's changing, not the logic beyond that point. So once you have the value in your hand, it's the base class's logic that's handling everything. So the behavior for all these config providers, if you will, if you had so many of them, would be the same. It's just the part that needs to be the part that accesses the actual data from the file or the database or a service, that will change, right? And again, as I said, there's a lot of information here in regards to the code. I'm not going to go through all of this again. I'm focusing more on the roles and responsibilities of the config provider rather than explain the implementation here. I've already done that in the other video, and you have the source code. Right? But if you have any questions or you think something is different or weird or you don't understand it, please write in a comment. Send me the comment. Yeah, you could send me the comment too. And I will respond certainly to your questions if you have any. If you're throwing exceptions, which you should be, because when I say you lock your front door and you lock your back door, I mean you lock it. And if the only way to sort of throw something back out, as in if you don't like it, even after you've tried to clean it up and trim it and whatever else, and you still don't like it, you want to throw it out. So the way you throw that out is through an exception. But if you throw exceptions, you also have a responsibility towards your consumer, because it's not fair to just throw an exception and not give them the information. So you probably heard me say this many, many times, and I'll drill it in your head again and again and again till you get it. When you throw an exception, you must provide the consumer or the other system with information that's going to help them understand the problem. So you say, oh, here's your problem, and you have to also provide them with the data that you received at the site or the location in which the problem occurred. So that it's not saying, I didn't like what you sent me, but what did you get? I mean, can you just tell me what I sent you so I can confirm that if I sent you an A and you're seeing an A, that is truly something I sent you? You know what I mean? So you must also include the data that caused the problem itself. And you must also provide them with possible solutions in cases where, let's say, there's if it's a valid date time, or it has to be a date time within this year, or it has to be a date time within this range, or whatever it is, you need to try and provide them with any information that is going to help them sort the problem out or fix the problem, right? So information, the messages should be clear. The data they sent you should be contained within the exception message, and possible ways in which to fix that problem should also be part of the exception message. But it's not necessarily anything to do with the configuration provider itself. That's just how you should do things if you throw an exception. I can't tell you how many times I've seen exceptions in message in large systems that are just completely clueless. I mean, they've gone through the hassle of designing the system in such a way that it would throw an exception, except they don't give you enough information to solve the problem or even know what was the real problem. You know, they're hiding the real problem. Anyway, I won't go into a rant on programming to exceptions. There's another video on that. You can take a look at it over here, programming to exceptions, in case you haven't already seen that. That's how you should be writing your systems. And this is how you should be writing your systems too. So guess what? Just follow all my videos and you'll be in a good place. All right. So having seen the base class, now let's look at the implementation in a .NET Core project as to how you would implement a configuration provider in .NET Core. Now there are dime a dozen examples on how to use the config system in .NET Core, but they all stem from like an ASP.NET application and injecting the thing provider from, using the dependency injection framework in .NET Core and so on and so forth. That's not how you should be doing stuff. There's absolutely no reason to inject at the controller level your configuration provider, right? I just would never do that. So I'm going to show you how would you get access to the configuration system in .NET Core from some class just embedded in your system somewhere and has nothing to do with dependency injection. So it's not coming all the way from the controller down, to yours, the classes that actually need a configuration provider. The two key methods really, the constructor is the main key method. Honestly, that's all it is. So you're setting up the configuration builder to use a JSON file, in this case, appsettings.json. So I actually have a appsettings.json file in my project. This is not there by default in .NET Core applications. So you have to add this as a JSON file. And also, if you want this thing to work, this JSON file needs to be deployed, if you will. When you build your .exe file and it ends up in a bin folder, bin debug, or bin release folder, this settings file needs to exist in that folder as well. So you need to, this is something that I'm not sure why they don't do this automatically, but you got to right click on this file and go into properties. And then this copy output to output directory, it's not by default copy if newer, but just make sure you pick the copy if newer. Now the copy always might sound like a even safer way to do that, but don't do that. It doesn't work the way I think you expect, or at least the way I expect. Copy if newer works all the time. So just pick this. I don't know if they fixed it since the last time I used it or whatever, but I don't even want to try it. Coffee if newer. Copy if newer is the way I see it. Every time the file changes, I want it to copy this new file back into that bin folder, right? Without doing this step, it's not going to work. So this is essentially how you get access to the .NET Core configuration system, and the .NET Core configuration system supports many file types and sort of listed sources from where to get the data. The JSON file happens to be one of them. It also supports the old style, XML file from .NET Framework, but typically, if you're doing .NET Core, most people are just using the appsettings.json file as the way to access your data. Once you build the configuration, you have a configuration root. And then the configuration root is used in the places where you need access to your configuration information from the file itself. And this internal constructor that takes in a configuration root and assigns it to the private member here is required. And when we do our unit testing, I'll explain to you, or you'll see it being in use, and therefore you will see it being used. And therefore, you'll understand the purpose of this internal constructor as well. The other key thing to understand here in the .NET Core configuration system is that when you're accessing, so let me show you the file. So this is the app settings section with a key here and a value here. The way you access it in the .NET Core system with regards to JSON files is you prefix it. So it's app settings : the key name. Right? So the app settings have been set up here as app settings, and this is JSON. So it's case sensitive. I'm guessing it's case sensitive. I'm not actually tried it, but I always match the cases. See, the thing is with me and names, they will always match. So I'm not even trying to know if it's going to work or not. I don't care. If something's called app settings in the config file with the uppercase A and uppercase S, that's how it's going to be in my code as well. I'm not going to change it. So if you get in that habit, then you'll not have the mistake. You'll probably be clueless as to whether it's case sensitive or insensitive. Who cares? The system looks clean. Things just match up. So app settings colon the name of the class, the name of the property you're looking for, the key you're looking for. That'll give you the value. So the colon is something you have to add in here. For any of these sections in the config setting, if I add another section here, in addition to app settings, there's some other setting here, the same thing would apply. Right? So you prefix it with the section name and then the key name with the colon in the middle, and then you'll get the value for that. So you can see in the configuration provider class, and this is another naming convention I have in my systems. If you look at the names here, you can see there's a configuration provider base and then there's a configuration provider. So this might be a bit backwards for some of you. Instead of saying base configuration provider, I'm intentionally saying configuration provider base so that all the configuration providers will all end up together. If there are more of them, you'd see them together in the Solution Explorer, right? And another convention I have is if something is called configuration provider, and that's all it says, configuration provider, that's your production class. So the base class has a suffix of base. The production version will not have that suffix. Right? So it'll just be called configuration provider. So basically the base class's name is decided by knowing ahead of time what you want your production class to be called. And then based on that, you name the base class. But there could be situations where you have variations. This is in production, let's say, right? So you could have a configuration provider local, meaning on the local machine, versus an Azure or cloud, it could change. So you can have a configuration provider cloud, configuration provider local, configuration provider database, configuration provider XYZ service. All that is the suffix is saying that that's the change, the implementation sort of detail of what's the difference between the local and the cloud and the database version. It's very easy, right? You understand. But they all appear contiguously in your Solution Explorer, which is why I named them seemingly backwards, but I've kind of got used to that now. So to me, it doesn't seem backward at all, and you will get in the same place if you decide to use this naming convention. All right, so because of the name here, this is called configuration provider, of course, the class. This is the production version. And you can see that in the production version, that's all is there in the implementation. And the bulk of it is, one is, how do you get access to the configuration system, if you will, it's configuration builder, or the configuration root in .NET Core versus .NET Framework. And then the two methods, and they're really essentially the same. It's not like there's any difference. It's just an extra thing here because of the fact that this is returning a DB connection information. We didn't even need this if we didn't have a database connection. So the only change essentially is this: how do I get access to the data? Once you have access to the data, the rest of it is the same. So it's all rolled up, if you will, into the base class. And therefore you don't lose the rules, you don't lose the roles and responsibilities and all the stuff that you might have baked into your base class, just because you have a different implementation. And while the different implementations don't have to worry about all the rules or repeating all the rules and responsibilities of the config provider, because that's in the base class, your descendants simply are saying, okay, I'm going to access the data because I know how to access the data from my database. I know how to access the data from my local file system. I know how to access the data from when I'm in Azure, and so on and so forth. The base class can take over from that point forward. So you implemented your rules and the roles and responsibilities in your one class in the entire system, right? It's not common, of course, to have different config systems in your system in production. But typically when you're working locally versus cloud, there are times when you might want to have the difference, if you will. And certainly there have been cases where in some systems, it's not common, and I hope you don't do this, and I'll talk about that second part as well. We had to store our config data in a database. And so, just change the implementation. Instead of coming from a local file, it goes to a database. But in production, you really have just the one class for the most part, right? This whole thing reminded me of another role and responsibility of just generally config files, not so much of a configuration provider, but config files. What you store in the config file, whether you should or should not store it, is important. In my opinion, and the way my practice, if you will, the way I conduct myself in systems I build, the only thing that goes in the config file is things that change from environment to environment. For example, I'm in a lower environment, let's say dev environment. my database connection string is this, and I'm dependent on 2 services, and the URLs are whatever they are in that environment. When I eventually get to production, the settings are different, as in the URLs are different. So that will be in my config file. If it's a setting that you might consider to be a setting, but does not ever change, it's not a setting. It could be a constant somewhere. In other words, I'm trying to keep as little as possible in a config file. I do not like config files that are so long and wieldy that nobody understands what's in it and whether it's configured or not configured. Right? Now, I understand there's a notion of what they call, feature switches, meaning you want to turn features on and off. I think sometimes people use those feature switches when it's not really a feature switch to start with. Right? So I think there's an overuse of config files. So be wary of too much information in your config file. If you need feature switches, it should be validly justified by the business. It's not a technical thing. You as a dev or as a dev team is not deciding to put a switch in there so that you can turn things on and off because you need them. That does not belong in a config file. But as a business, if you need that feature to turn some feature on or off, or maybe you're building the same a system that works across multiple customers, it's the same code base, but different customers have slightly different requirements. And so the feature switch will allow your system to behave in a different way. That's certainly a valid use case or is a valid feature switch that belongs in the config file. All I'm saying is you want to make sure your config file does not have any more information than it absolutely must have. And certainly developer needs, feature flags or feature switches, they don't belong in the config file. That's not a business requirement. It's your requirement. For whatever reason you want to turn on debugging or this and that, I'm sorry, it does not belong in the config file. If that thing goes to production like that, you'll be sunk. I've had, not personally, but I've known of teams and people on those teams who've suffered tremendously because they put something into production that was supposedly a debug thing, and it turns out that their data did not get saved in the database for two weeks. It is not a funny place to be. It's not a pretty sight to have, or a position to be in. So don't ask for trouble. If you simplicate, you won't be complifying, right? Anyway, that's all I had. I hope you enjoyed this video. The source code, as I said, will be in the description below. Thank you for watching. Appreciate your comments as well, and I shall see you next time.